Welcome to World Salon and KIIT event, Digital Fireside Series, new applications of AI, harnessing AI for innovation, growth, and success. So today we have a great session with us. We are having Patrick Bukema, Michelle Bachman, Kawala Shinobi, and Julie Wall. So I am Dr. Murari Mandal. I'm a AI researcher in the School of Computer Engineering in KIIT Bhubaneswar. And we will begin our session, today's session, with our first speaker, Michelle Bachman, uh, who is a human-centered AI scientist at IBM Research. And she is currently working on mental models and information needs for users of AI system and users involved in AI governance, particularly surrounding generative AI and agentic AI systems. She was previously assistant professor at computer science at University of Mass, Lowell, and received her PhD from Washington University at St. Louis. And her research has roots in understanding and designing systems to support novice and end user programmers. She has papers at venues like ACM CHI, CSCW, and IUI. And she has also won 2 Best Paper Awards at IEEE Conference on Visual Languages and Human-Centric Computing. So, so we begin, Michelle. So you can start and start with your points and share your wisdom with us.
Sure. So, yeah, I'm at IBM Research in Cambridge, Massachusetts, and my work is really around knowledge workers, people who work in businesses, and their needs in using AI systems and generative AI systems. And I think one of the kind of important findings of my research recently has been I'm always thinking about people and how people are using these AI systems. So generative AI is really powerful, right? We all know that. It's not really a question, but it in itself, without sort of adding more to it, it ends up lacking. So, uh, for example, when we're thinking about people who are using a large language model, kind of in isolation, they're missing a lot. They're missing access to data. They're missing access to up-to-date information. They're missing a lot of capabilities. And so what we've really been thinking about lately is how systems kind of need to be more complex and broader than just the generative AI capability and connected to a lot of the capabilities that people are using throughout their work, and integrated into their workflows so that they can use generative AI as part of their workflow as opposed to as sort of an isolated capability. And so that raises a lot of questions as well about how we can make sure that the information they're getting from these systems is something that they can evaluate appropriately to make sure that it is actually useful and accurate for their workflows. So, so recently I've done some work where we looked at people using an AI system, and they really often trusted it to work well. And we're finding that people are really not always able to accurately evaluate the outputs of these systems, especially as they get more complex. There's more going on in the background, and people are lacking a lot of the mental models they need to be able to accurately judge whether the system responses are going to be accurate.
Sorry. So how have these generative AI has transformed the design of like these human-centered systems? Like, what are some of the changes that we are observing since the advent of these large language models in terms of end user programming, in terms of collaborative collaboratively working on projects at industry level? So what are some of the changes that you have observed since the LLMs have come on the scene?
Yeah, so there's a lot of um, need for evaluation of these systems and considering how the people are interacting with the systems. So we need to think a lot about uh, how do we enable people to interact with them effectively. I think it's kind of easy to think that people can just always put in natural language and sort of be able to easily specify what they need from a system, and that's not always the case. Sometimes people aren't able to kind of specify what they need in a way that the generative AI always gets them to their final answer. So even though there's a lot of power there, there's still a lot of need for supporting users in interacting with the systems effectively. So we still need a lot of kind of work toward enabling users to interact in ways where they get the outputs that they need and that those outputs are accurate.
So anyone else would like to chip in on this? So I have been like observing, like I've been using a little bit of these cursor and a bit of V0 as well. So they seems super duper helpful to programmers, right? uh, and like I think earlier Microsoft launched Copilot, and then we are seeing better and better, versions of that. I don't know, like the functionalities are slightly different, and they are coming from different, different side of usabilities. But how is that going to change how commercial or enterprise grade the softwares are built? Because we heard on the news as well, like even the Googles, and they're also saying 30%, 40% of their codes are now being written by AI, right? So how the future, people who are looking for, to get into engineering or software engineering in future, how should they adapt to this kind of scenarios?
Yeah, so I think that uh, we always need to be working in collaboration with these AI tools rather than sort of handing things over. And they can't replace sort of the human problem solving process, I think, at this point in terms of software engineering. Um, and there's still so they can generate code, right? But we still need people to check over that code to make sure that the code is solving the problem that's needed, to make sure that it's going to connect to other pieces of the code. Um, so I think that the core skills are still needed in terms of software engineering, and that that these tools are their assistants, right? They're ways to expedite things, but they're not at this point replacing people. That's my opinion.
Yeah, I guess we need to now people to verify or like evaluate these LLMs, and because at the end of the day, like persons are going to be responsible for the failure cases, right? We cannot just blame the LLMs if your software fails, right? So we need these verifiers kind of roles that's going to come up, and again for that also we need the expertise, right? So the verifier also needs to have the same expertise that we were expected earlier in terms of programming, in terms of those roles. So I guess the it's just changing the role in the industry, rather than like what AI is going to take the jobs away. So right.
Yeah, and I think sometimes verifying the output can be harder than than just writing it yourself, right? Because you have to though it might not be written in the way that a human would write it necessarily, and often understanding code is a really challenging part of the software engineering process. So there's still some really significant human challenges there. And we also need to think about how these systems can make sure that people aren't over relying on them, and how do we make sure that people are really verifying what's coming out of them. So there's some kind of challenges on both sides of those systems.
Yep. Yep. Okay, so our next expert, Professor Julie Wall. She is a professor at AI and Advanced Computing at University of West London. So, and she's also a member of British Standard Institution and serves an expert in the field of AI. Her expertise has been vast research on neural network architectures and biologically inspired designs, computationally efficient machine learning, and so on. And she has also developed production grade deep learning and NLP understanding systems for a variety of platforms, including virtual and augmented reality environments. And her research contributions have been widely recognized through publications in US and UK, and also patents in US and UK as well. So the question, so Julie, the question we have is, how has the rise of generative AI transformed the development of efficient and production-ready systems for speech and language processing systems across multimodal data and virtual and augmented reality environments?
Thank you, and thank you for inviting me today. So my research started off with neural networks many years ago, pre-deep learning. So I've been interested to see how we use these types of intelligent systems to process temporal data over the last 20 years. So it started off with spiking neural networks, which I believe are making a bit of a comeback, to the rise of the deep learning 10 years ago, more than that. And then particularly in the last 10 years, I've become very interested in natural language processing and processing speech data and textual data as well for behavioral insights. As an academic, I teach students, so I teach machine learning, how to be researchers, how to be the next generation of software engineers. But I also am very keen on research as well. And I have been fascinated over the last couple of years as kind of the generative AI has become so commonplace. It's as you say, it's a topic everybody's talking about, and it's really changed. It is changing the way that we approach speech and language processing. So prior to even a couple of years ago, we would have been using very bespoke natural language processing methodologies, smaller language models to mine and to search through and to process speech and audio to derive kind of insights into conversations. So looking at what people are saying and how they're saying it and what they fundamentally mean. And with the large language models, they are now able to process different types of data, text, audio, video, all together. And in best case scenario, work together very seamlessly. So these advancements in the last couple of years have really made the systems, the AI systems, feel very natural and responsive. And then, of course, this leads to better quality, in theory, systems in customer service, education, etc. So the applications that come from that are transforming those areas as well. So natural language processing has really shifted towards natural language understanding and then the generation of natural language as well. So using these types of large language models and being able to synthesize natural language or natural sounding outputs, it means that we're able to better understand conversations for different use cases. So one of the projects that I worked on more recently was looking at using conversational AI for fraud detection. So it was a project done for the insurance domain, and it was looking at the conversations happening between customers and their contact centers, so the agents in the contact center. And the aim of the project was that we wanted to look at trying to identify suspicious behavior. And insurance companies have this kind of a balance between they want to detect fraud, which ultimately should bring down premiums, so it's kind of better for everybody. But they never want to accuse a customer of fraud mistakenly. And that's a big issue that they're very concerned about. So when we worked on this project, we looked at using, this was around 2020, 2021 even. And so we were looking at using at that time, state-of-the-art language models to detect markers or features in conversation. So we would look to detect individual markers, like disfluencies, like the way I'm talking now, using ums and ahs and pauses. We would look for hedging, uncertainty, over-explanation, so explainers, and we would look for negation terms. Some of the existing machine learning models worked very well, very simple models, as simple as a bag of words, right through to using a language model. And then a decision engine would be employed to process all of that data that was detected, to provide an explainable way, similar to what Michelle was saying. Do we understand why the system is making a prediction of this is suspicious? So it was very important that not only were we were able to make that decision, but that we were able to understand why the system was making the decision. And since in the last 2 years, this work has progressed to using large language models for that. And a lot of the effort has gone into the prompt engineering side. So providing the language model with some examples of historical data, but the engineering is really in making sure that the prompt is looking for all of those different features. So what would have been a very open kind of ensemble of machine learning models and small language models, all running concurrently over a transcript, for example, is now being processed by a large language model. So there is concerns there around the kind of, are we going back to that black box AI where we have an interaction in terms of the prompt, and we tell the language model what to do, we give it an example, we can write a really large script of rules of what we're looking for, but that large language model is processing all of that data, customer data in particular, and making a decision. And we can ask the language model to tell us why this particular conversation was flagged as being suspicious. But the transformation I can see is that the system is potentially simpler, i.e. the pipeline is simpler, but there are problems with using large language models in cases like this, where before we would have had a very bespoke, kind of clear, transparent, explainable model making decisions on customers. And now we have a very clear, explainable prompt, which is being passed into a large language model. So that is one kind of impact that I can see, is that the technology is much more mature, it's much more sophisticated, the levels of functionality that we can achieve are fantastic and they're growing. But I do feel that the ethics side or the explainability side of understanding how these AI systems are coming to this particular decision is a problem. Other problems could potentially be, sounds very negative, other problems could potentially be around the bias. So these large language models are trained on, extremely large, huge data sets. And obviously any bias in that original training data is trained in. And even with a very large, very clear prompt, a very prescriptive prompt, there is still potential for the bias in the knowledge base of the large language model to influence the decisions that are made. So that is something that's to be aware of, and it's something that needs to be considered when these systems are employed and used in in customer service, used when decisions are being made that impact people. So yeah, I can see that the impact is we have very sophisticated technology, which is a great positive, but the ethical concerns around the bias and how the decision is being made is something that I think we will continue to work on. I guess the last thing will be about whether large language models should always be employed around the area of like sustainability. There are so many startups that seem to be running on a business model of we have a large language model at the base to deliver a particular service. And the conversation should always start with, well, is there another way to do it? Is there, can we use machine learning to deliver the same level of functionality? Do we need to use all of this computational power, all of this energy with a large language model to produce the same particular output? So the expense of the language model, the amount of energy is something that we should be considering as well. Obviously, the newer models like DeepSeek, which still I think needs to be investigated more in terms of how comparable it is to the existing large language models. So there are newer models coming, which is interesting, something to watch. But yeah, the transformation on the field of natural language processing, I think, has been huge in the last couple of years. Very interested to see where it's going.
Okay. That's interesting. So, in aside this bias and explainability, all these issues that we are still working on in the large language models. So, did you notice a substantial improvement in your solutions when you move from your traditional machine learning based solutions to, let's say, LLM powered solutions?
Not hugely noticeably, but the work became, when this was deployed in in insurance companies, the engineering work moved from analyzing the data, training the individual machine learning models to detect what's interesting, to flag up interesting conversational AI behavior, and it moved towards the prompt engineering side. So that's where the work moved towards. In terms of the performance improvement, that really depended on how well the prompt was written, and how much information was given. So it became a different type of task. And in terms of performance, the machine learning worked very well. So it was looking at, could they do this with LLMs and achieve the same level of performance?
Okay.
But it's slightly simpler pipeline.
Okay. Thank you. So my next question is to Patrick. So let me introduce Patrick Bukema. So he's a principal AI engineer at Allen Institute of AI. So Patrick is a scientist and engineer and passionate about building AI for social good. He leads a cutting-edge AI initiative at Allen Institute of AI, where he focuses on global scale, real-time AI systems, including advanced satellite computer vision and GPS transformer models. His contributions have set industry benchmarks and delivered benchmarking solutions across multiple domains. Patrick earned his PhD from University of Pittsburgh and Carnegie Mellon University, where his research explored neural activity patterns evolved during learning. So before AI2, he has played a pivotal role at MindX, a startup from Johns Hopkins Applied Physics Lab, where he designed machine learning systems for facial recognition, object detection, and brain decoding. So, Patrick, my question is, how can interdisciplinary collaboration and open science practices be combined to develop scalable AI solutions that address global challenges like climate change, biodiversity preservation, sustainable resource management, and at the same time ensuring community engagement, inclusivity in during that execution?
Great question, and thanks for having me. I'd like to provide a little background about AI2 for folks who are not familiar with our group. So we are a nonprofit based out of Seattle. We're a nonprofit artificial intelligence research institute founded in 2014 by Paul Allen. we build foundational AI research across many different domains, large-scale models, data, robotics, environment and conservation, which Murari mentioned, and beyond. We have 4 key, I would say, values that drive our development. So one is openness. So we think a lot about, what openness means in the context of artificial research and development, and we pay a lot of attention, and we strive for, the most open research and development that we can in the industry. So I mean, you can literally go to GitHub right now and you can download training artifacts for building your own state-of-the-art large language model. You can download the data from Hugging Face. You can download pre and post training recipes for for the models. You can download the evaluation code. And so you can literally download all of this right now and understand how we build LLMs, how how these things are evaluated and refined. And so we care a lot about this. We see it as really central to the development of safe, ethical, and performant artificial intelligence. So we're deeply collaborative, and I think that's probably I think this question that you're asking, Murari, it's a critical question. And I think because we're a nonprofit and we kind of sit between, we have fairly deep collaborations with many different groups in academia, in industry. We have users who are, spanning the entire planet, and many different organizations, government organizations, environment, conservation groups, other nonprofits. So we're quite collaborative, and again, we see that as, I would say, central to strong artificial intelligence R&D. So we have, when we build artificial intelligence, we think about not just the research, which is critical, of course, but also the engineering. If you build the best model in the world, but no one can access it because you can't deploy it or because it's hard to access, then it's going to be less impactful, right? And then at the same time, you want to think about, what do users really need? So there's product questions that are central to the development of AI. And I think, we've learned a lot over the last, 5 years, I would say, since AI has become increasingly popular. And, as Michelle mentioned, it's not always obvious how users want to interact with this technology. And we want to build the artificial intelligence that actually enables them to do, what they want to do. So, I mean, literally, it's as simple as asking users, what is your problem? If you're doing biomedical research, and we think a lot about how to build AI tools for accelerating science discovery, for example, what are scientists struggling with, and how could AI serve them? So when we think about impactful AI, yes, we're thinking about the research, that needs to be done to solve some fairly large open problems, but we also think about, what precisely, how do we best build the AI to serve users' needs and to serve humanity's needs? Because ultimately, our work is to solve, or our goal is to solve what the world's biggest problems, across science, biomedical research, climate change. So that is our mission, and I'm going to stop there and see if you'd have any follow-up questions, or if I can go into more depth in any of those areas.
Yeah. So, what are some of the important directions? May not be just LN AI, but in general, that we should be exploring right now with AI for social good. What are some of the top 3 to 4 priorities you feel?
Great question. So AI2 has a number of programs, as I mentioned, across large language models, which are all developed in the open. robotics and environment. So I lead our environmental artificial intelligence initiatives, and these span both conservation and sustainability, but also climate change. So what we generally do is we we look at kind of the largest problems that exist in say climate change or conservation, and then we ask how can we build artificial intelligence that helps users who are addressing these like critical problems. I'll give you a concrete example. So maybe some people here know that some of the largest models in the world are climate and weather-based models. These are typically physics-based models, so not necessarily artificial intelligence-based models, but literally the largest supercomputers in the world, or I should say some of the largest supercomputers in the world, are weather forecast models. So all the the biggest countries have these, and they're building or they're running these simulations so that we know like where's the next hurricane going to be, where are the next floods going to be, extreme precipitation, that kind of thing. So these are extremely critical models, but they're super expensive to run, and they're very energy intensive, and they require these large supercomputers that I mentioned. So they're physics based. It turns out that you can design artificially intelligent models. So think about, kind of transformer-like models that are designed to replicate what the physics-based models are doing, but at literally 1/1000th the energy cost. So for example, our climate team at AI2 has a model, it's called ACE. It's again in the open, just like all of our work. And it reproduces at very high fidelity these extremely computationally intensive physics-based models, but for 1/1000th the energy and cost. So what that means is you can do many more simulations, you can do many more experiments, you can kind of democratize access to these extremely critical sources of intelligence to a much wider user base. And of course, you're going to use less, less energy, less water, less carbon output from the AI-based models. So that's just one area. There are many areas spanning, environment, conservation, sustainability that are critical to the planet, and we have many programs that are fairly mature, addressing various elements in this space. I want to give one more example because it's a fun one. So we have a maritime intelligence platform at AI2. It's called Skylight. Skylight is a free a tool that's in use by hundreds of organizations worldwide, and it takes in tons of satellite imagery, not just satellite imagery, but that's one of the key sources. So literally there are petabytes, hundreds of petabytes of satellite imagery that are generated from the major satellite imagery providers, European Space Agency, NASA, India, and these folks, or sorry, these groups have tons of public access data that is provided in real time to the public that you can literally download right now. And so we've built computer vision models, again, in the open, all bespoke at AI2, that do object detection at global scale in real time and surface all kinds of interesting events that our users need to know about, like on the high seas where there's no cameras out there. The only way to see what's going on the high seas is the satellites, satellite imagery. So we've applied and deployed a bunch of models to take in all the satellite imagery and then say like, oh, here's vessels on the high seas, here's oil platforms, maybe here's renewable energy infrastructure, that kind of thing. And all of these models are running continuously in real time, processing terabytes of data. Skylight covers literally at this point every single country's EEZ, exclusive economic zone. So that's another example where you can take artificial intelligence, you can take public source data, and you can build tools that are going to be in the service of, say, conservation, food security, and we give this technology away.
Okay, that's great to get the insight. Thank you. So maybe we'll come back to some more questions. So we're moving on to our next speaker, Kaola Shaboni. So Kaola is a PhD student at McGill University and Mela, and she is currently under supervision of Professor Gurnush Parnadi and Jackie Shikit Shion, and currently she is doing research in fairness, privacy, and other safety challenges in large language models, with particular interest in low resource languages. Uh, so, Khawala, the question for you is that, so as a both researcher and former senior data scientist, how have you navigated the gap between cutting edge academic research and practical AI deployment in industry or government settings? And again, so what are some of the lessons that you have learned on your way to both industry and academia?
Hi, thank you for having me. So yeah, I'm currently doing a PhD, and before that, I worked as a senior data scientist at Statistique Canada. And basically, I was working more into research in responsible AI. So what we were doing is like we were doing some part research, and another part was auditing other teams project for the ethical side, like the bias, the fairness. And I've also done this kind of work in other settings in industry, basically auditing model developed by data scientists. And what I realized doing, like, I've been doing like fairness research for the last 4 years, is that there's like a huge gap between what's actually being done in real life and what we do in research. And mostly it's because there's a lot of real life constraints that we don't take into account at all when we do research. For example, a lot of fairness research rely on having access to protected attributes. So having information about the gender, the ethnicity, age, but this type of attributes in a lot of real life settings are not even collected because of data regulations. Um, Same thing, like I work in large language models, and usually when I do my research, I always evaluate like on like bigger model, the most recent model, but in sensitive application, especially the one that are customer facing, a lot of like I've seen banks or like in government also they don't want to have chatbots interaction with the clients because of the safety challenges, the issues like with toxicity or hallucinations. So they deploy another kind of model, more old school models that we, especially right now, like we don't work as much on. Um, Another issue that I've seen is that like um, in my like in my work as a researcher, I offer like I give like workshop on like fairness and safety, and sometimes I realize that people don't know much about the subject. Um, LLM, at least LLM have help with getting this type of subjects more popular because now everyone knows about like hallucination or like that your LLM can say toxic things. But except of this very specific scenarios, most people don't are not very familiar about how bias manifests. So you have like, for example, this data scientist creating models, but they don't necessarily know that at the data set collection stage, you should be looking at the distribution, for example, of your data set, or at the quality of the data set, because it will impact later on. Same thing during the design of your model, you should be conscious that the fact that the decision you're going to make are going to have an impact on the final model. Like maybe it's gonna exclude some groups or like perpetuate some patterns that exist in the training data. And usually what I see is that like these models are developed, and then at the end there's the testing for safety, whereas like the safety part, the fairness part should be like here from the beginning. So there's really just connect between how things are being done and how they should actually be done to have an impact. And also what I've seen is usually, so the responsible AI part is like a separate team or a separate division. So that's why like you don't really have an integration. Even in well-intentioned organization, it's not like the ethics are not integrated into the day-to-day practices. And usually you have like a small team of maybe 3 people that need to audit and take care of the responsible AI part for like hundreds of projects happening on the same time. Whereas like when you do research, it's things you don't really take into consideration. Like all my papers in the recommendation phase, there's like you should do that, and that, and it takes a lot of resource that don't exist in practice. Things are not really implemented. And also, these things that like since usually in computer science, now I know it's changing. I've seen a lot more courses on like responsible and trustworthy ML. But most of the people that have been trained before, they do not have this type of classes. So either they know about it because they learned themselves and they were interested and they had training, else they don't know about it. So even when they're interested into testing models for issues, they don't really know how to go about it. So this is some of the challenges in real life that I've seen. And like there's also this benchmarking culture that's in like the research and side. That's what like my research is about. Basically, I'm interested to see how to better evaluate models. But in the case of LLM, the benchmarking model is also in the industry side. Like every time you have a big model release, you have all the stats. Oh, look, we have 0% toxicity score on this benchmark. On this benchmark, we have the safest model on the market. But then when you look more closely into the model, you still have the same biases. And it's because what I try to show in my work is that there's really this culture of competitive benchmarking when practitioners are trying to have the highest score possible on the benchmark rather than actually improving for the task. So for example, when you're doing safety mitigation, like the goal is going to be to have 0% toxicity score instead of actually having a less toxic model. And this, it shows really fast when you deploy that model in a real life setting that's very different from the benchmark you're actually using to evaluate your progress. And you realize the model has still exactly the same bias despite the incredible results on the toxicity benchmark. And this has really been happening a lot in like in large language models. Like most of the large language models deployed today are still pretty biased, and they have incredible scores on all the safety benchmarks. So yeah, this challenge. There's also the fact that this benchmark, they have been like online for maybe a decade, or the most recent one for at least a couple of years. And we know that like LLMs are updated with training data from like scraps from the internet. So there's also concerns of validity of like the results you're reporting. Have you trained on the benchmark or not? And then there's also this issue of like lack of realistic scenario. Usually like you test your LLM with red teaming. So you have people like for the organization that have more resource, they try to do like multi-turn. So for example, having a conversation, but then at some point it's still limited in time because of course, like if you have a model like ChatGPT with people who interact with this type of model every day, and then you only test it on maybe two-turn conversation, like it's sure that like the scope of your evaluation is very far from what actually is happening in real life. And this is like open research question, I guess, and the real challenge of how do we actually make sure that this model are safe for, like before they are deployed.
Yep. So as they say, evals are all what you need, right? So that's what we are right where we are right now in LLM game. So yep, definitely I think we need a lot of, even I myself am doing research in this LLM evaluations because it's a very important area. And yep. So with this, we now move on to general discussion questions. So now these questions are open to all. So guys, go ahead and I'll ask the question, and any one of you who wants to answer the question can answer the question. So the first question is, so some of these questions are curated from the participants. So we kind of combined the questions which the participant wanted to ask and made it generic questions. So the first question is, how do companies and research institutions balance the trade-off between practicality of AI models that they're developing and the sustainability, or I would say, I think some of it was covered, like the fairness or responsible kind of AI deployment or responsible way of developing these products. So how do an organizations, the companies balance these two? Like at the same time, you come up with the innovative solutions. At the same time, you also keep in mind the the shortcomings or the negative impacts your solution may have.
I'm happy to start on that one. I was interested to hear Kula's point of view about, how ethics, privacy, and are actually applied. From my understanding, I think there's definitely a gap between responsible AI development from a research aspect and how we can do explainable, transparent models, and how industry uses AI. And they are very concerned with regulations and standards. So the AI that is developed in a commercial sense as products and services, the main emphasis will be on making sure that they are within compliance regulations, especially financial services, etc. So I do feel that the focus from industry is on the regulations and standards if they choose to apply to a particular standard. So the scope is for more responsible AI. I think AI could be developed in a more responsible way, but the reality is that the regulations are key. So maybe having obviously ongoing changes to regulations here in the UK. There's always, and I'm sure across the world, the EU AI Act, there's different approaches to regulations. In the UK, the focus is on encouraging innovation, but as a priority, and the regulations are focused on the industries themselves. But yeah, my point is that there is a gap between what we can do and what is actually being done.
Okay. So the next question. Okay, sure.
Yeah, I was just going to mention that. So I work within a responsible AI group, and there's a couple of things that happen that I think may not be so obvious to people who are sort of out on the outside. One of which is that our teams not only develop really large models, but also smaller models. And there is a need for these smaller models. There's a variety of benefits to them, including some of these more responsible aspects, but also, they can be easier to fine tune, for example, for more specific business needs. And sometimes those smaller models can actually end up being better for particular use cases, because they can run faster, they can run, with less GPUs, and maybe customers don't have a lot of GPUs, like things like that. So I think there's not only the need for these really large models, but also smaller models that can address some of these issues, is one thing. And then another thing is that I think what we see from our sort of business to business perspective is that a lot of companies do really care about some of these considerations in terms of the responsibleness of what they're presenting to their customers. And so our team, for example, has developed something called a risk atlas, which has a sort of dictionary of risks that are defined, and we're working on things like making it easier for people to understand those risks and figure out ways to mitigate them. So there are kind of things like that that are going on there that may not always be in the forefront of the news, but they're kind of happening within some of these teams.
Yeah, sure. Thank you.
I think it's very challenging because the speed of artificial intelligence is so fast. I mean, this field moves incredibly quickly. You know, as we saw, like I think over the weekend with DeepSeek's announcement, and that was, I think, fair to say, a surprise to a lot of big players across, you know, across industry and academia. So, you know, it's difficult to kind of respond and I think, you know, adequately address everything that's happening in artificial intelligence. But you know, we do have to make a serious effort because the safe and responsible, you know, development needs to be a priority. And I think, you know, openness can help with that. So, you know, Kaula mentioned that, you know, some of these models, it's not clear how they were, say, evaluated, or perhaps the benchmarks were included in the training data set, or, you know, and some of these things might be more kind of industrially focused, right? Or like, you know, primarily kind of like the incentives are going to be more financial than, say, like safety or like from an ethical perspective. But a lot of times the incentives are aligned as well, and, you know, across these different groups. And, you know, it is possible to release, you know, open models, for example, and release the, you know, release the artifacts that enable the public to inspect, you know, how these things were trained, you know, how they were evaluated. You know, there are numerous, you know, organizations releasing, you know, open models.
Yep, it's true. So I think we have time for one more question. I think on this, I would think everyone can share their advice. So what advice would you give to a student who want to transition from academic AI knowledge into industry roles such as AI engineer, researchers, or data scientists? So anyone can go first.
Okay, I don't mind going first. What I would say, especially with the job market right now, is don't hesitate to reach out to people that have, like, for example, if you're applying to a company and you have there's someone that has the job you want or works on the team you want to work on, you should reach out to them. A lot of the time, like most of people are hired either, from what I've seen at least in this position, it's either internal hiring or someone referred you. And also, even if they don't refer you, people are usually helpful. Sometimes they will ignore you, but when they answer, usually people have good advice. They can help you prep for your interview, tell you what the team is looking for, what's the culture of the company. And also, my second advice regarding to this is that, yes, you're looking for a position, but you're gonna spend like maybe most the hours of your life in the, like, of your day, at least like of your week there. So it should go both way. Like, you should also be looking for position that fit with you, not only but like for everything, for the culture, for your for your, like, you should also be basically interviewing your employer, not only on one side. Even if it's, the job market is rough, I think it's always, for me, like, quality is more important than quantity. So for when I'm looking for things, I usually isolate like maybe 10 positions that are a great fit in both ways. Like, they are a great fit for me, but I'm also a great fit for their team. uh, and then I spend a lot of time like having a very high quality application. I reach out to people, I talk to people there to make sure that this is a position that will be good for me. And I really
What
invest.
are the modes you adopt while reaching out to people? Twitter, emails, LinkedIn? So could you share
um,
something?
I usually use either email or LinkedIn. Yeah, because I'm not on Twitter, but I know a lot. Twitter actually works really well for academics. Most people I know like mostly use Twitter, but I'm not there. And yeah, usually I just like I talk a little about myself, like quick background. I also explain why I'm reaching out to that person specifically, because people get a lot of requests. I also like, for example, for me on LinkedIn, I get a lot of requests, and usually if the request is generic, I don't take time to answer because I don't have that time. But when I can see that I can actually help this person because of my own experience, then I usually always take the time. So make sure that the person you're reaching out like is relevant for you and for what you're looking for, and explain why you're reaching out to them. Talk a little bit about yourself, and yeah.
Okay.
I want to give some more practical advice. The field moves really quickly, as we discussed, and it's tempting to get caught up in all the hype, and even like it's tempting to get caught up in the latest framework or the latest kind of like way of deploying or some startup or et cetera, and because the field moves so quickly, and because we haven't yet reached, I would say, like all that much stability from kind of a serving and inferential deployment perspective, which is obviously top of mind when you're actually, when you're in a product or industrial setting and you need to deploy these models for specific users. So what I would say is instead of, concentrating on these like very specific kind of fast moving and relatively unstable pieces of artificial intelligence, think about the major problems that the world is facing, and think about problems that are going to be around in most likely several years, 5-10 years time, and then develop figure out what you're passionate about, of course, but like develop expertise in helping solve major global societal challenges, climate change, food security, extreme weather. Like if you attach yourself to a specific framework, you're at risk of that thing literally not even existing or being irrelevant when you're actually in have an opportunity to use it in an industrial or large enterprise setting. If you attach yourself to a problem, then it doesn't really matter what is happening day to day or month to month with with some core piece of technology, because you're trying to solve a much larger, harder problem. And there's plenty of problems that the world is facing that would benefit from artificial intelligence. And, so I'd encourage folks to think about, using AI for the benefit of the common good. I think there's no doubt everyone would agree that artificial intelligence is going to change the world, and it's on us to ensure that the change is for the better.
Okay. So I think I'll add one follow-up kind of sub question to it. So how much a person when in undergrad studies should get into the detailed understanding of AI with mathematical foundations and all those things, and how much versus like how much to spend time on, because nowadays we have APIs, right? So we can just use these APIs to build lots of fun applications, not even very nice applications. Application layer is what we expect most products to be developed, right? So what is the balance? So anyone would like to share that?
Maybe I can start. So when we're preparing our students for graduate roles, one of the big things that we would hope that they would have would be kind of critical thinking, so that they can apply the technical theory or their experience that they've gained during their studies to the new problems, to the big problems that Patrick mentioned, or the specific use cases of the company that they go into. So it's how can they take what they have learned and actually understand what the problem is, understand the data that's actually relevant to that problem, and how, what are the restrictions around that data. So it's critical thinking and understanding, trying to really understand the problem, the data, what's the appropriate type of, there's lots of AIs, it's not just language models. What's the most appropriate type of AI to apply? Not necessarily just take the newest, most exciting AI and say, let's use this, but it's really taking the time to do a bit of research into the particular problem that they will face in a graduate role. So I think that's something that they could definitely consider: critical thinking, reading around a subject, understanding a problem, and not just applying, let's apply machine learning here or a Python library, without actually taking the time to understand what the problem is.
Yeah.
I would say that some of your question is, it depends on what kind of role you're looking for. So,
We are talking about more AI related roles. So yeah, like
I mean, like research scientist versus an AI engineer, those are going to be, the AI engineer is going to be a little bit more on the practical side. They obviously still need the fundamentals in the mathematical concepts, but their role is going to need more of those skills that are really integrating the AI with other tooling, and really being able to connect those pieces, and not necessarily focusing on one particular, framework, but understanding kind of how those components fit together to build a larger system. Sort of how our AI engineers are typically working versus a research scientist who's maybe more focused on, the theory behind the model, improving the models at kind of more of those theoretical, at the theoretical level. But it's still, I think a lot of our research scientists are doing a lot more of that integration as well, where they're actually kind of working to develop pieces of software and needing to really understand how kind of all of those pieces fit together. So I would say that sometimes in school you can get kind of focused in on just the theory, and not really understanding how a larger piece of software is built and how things need to fit together.
Okay, yeah, that's true. So time's up for our discussion. So now we'll start our breakout sessions. So just give me a few seconds to start the breakout sessions. Yeah, so before moving on to breakout sessions, I'd like to thank all the speakers and experts. So it has been a very wonderful discussion. I hope our audiences enjoyed as much as I personally have enjoyed our discussions. So it really put a very nice kind of overview on the current AI directions, applications, and what the students need to look towards to transition towards research or industry roles. And from I would like to thank everyone to come and join us in today's discussion. It was a really insightful session, and hoping to see you guys again sometime. Okay, thank you. And just hold on. Let me create the breakout sessions. So just give me some time.